it's respiratory system, and then I think it's also in AQ1. So then we go to the nervous system a bit, but I know it's immune system. So you will not be understanding so much here, but I just want you to know that the autonomic nervous system is the involuntary portion of our nervous system. So those things you cannot control. And it is divided by sympathetic, which is action, parasympathetic, which is relaxation, and then it is only a motor division nerve. When you say neuron that is motor, it's only will transmit the process information to the effector cells. So it's not the sensory part of your neuron. It's the motor part of your neuron. Okay, so in this case, these are the signals of your sympathetic and your cranial nerves. If you look here, you have your vagus nerve, which is cranial nerve number 10, which is very important for the action of the heart. Whether it is tachycardia, very strong, or bradycardia, which is very slow. So we'll study your heart rate, cardiac output, and stroke volume. So heart rate is the number of beats per minute. Okay, it's per minute. It's not per second. So we have at least at rest. What you're doing now, you're resting. You have 60 to 80 heart rate. So we put 75 the average. Okay. So cardiac output is the volume of the blood. So that gets out of the heart per minute. Again, it's per minute. Okay? So at rest, you're pumping 5 liters, almost 5 liters, or 5.04 T millimeter, or 5 liters per minute. So practically, in your body, you have 4 to 5 liters. Men have 5 to 6 liters more of a minute. So practically every minute, all your blood passes through the heart. See that? How heart is very, very, very powerful in your body? Because all your volume of your blood passes the heart to be pumped all over the body. Yeah. Okay, so another term is stroke volume. Stroke volume is the amount of blood pumped in one heart rate. So that in our computation, remember the ejection part, we have 70 ml volume, the ejection, okay? And then 50 ml remains in the ventricles. So that's per minute. Now, if you look here, so the stroke volume is about 70 ml, okay? But remember that where the cardiac output is also the volume per minute. So this is wrong. This is 50 ml per what? Per beat, not per minute. Okay. So that 50 ml per volume, per heartbeat, you have 75 heartbeat. So multiply 70 times 75. That's the cardiac output that you have. You got it? Okay, this is very important information. Repeat, 70 ml per beat. Your cardiac output is volume of blood per minute. So you have 75 beats per minute. So 70 multiplied by 75. How much? Hey, use your calculator. Don't just do that. Yes, you've got to be active. Yeah.
75. 520.
0. 5 liters.
5 liters, yeah.
Yes. That's your 5 liters per minute.
Which is the 75 what?
How much in reality? How much really?
It's 5250. 5,250.
Yes, that's exactly 5,000, 5.2 liters.
What's the 75, Professor?
Beats
Beats
per minute.
per minute.
So 1 beat is 70. So 70 multiplied by 75. That's your cardiac output.
Okay.
This one is an example of a heart on rest, but didn't say how many beats. But you know the beats, right? 1 beat is 70 ml. So you just multiply it by the minute, by the 75, because 75 beats is the beats per minute of your heart.
75.
Okay, you got it? Okay, now, a stroke volume is the amount, right, per heartbeat. So it's the difference between the end, that systolic volume, and then the end diastolic volume. So we have these. The end diastolic volume is 120, and then the end systolic volume is 50. That's why we got 70. 120 minus 50. Hey, minus 120 minus 50.
70.
Okay, now that's the stroke volume. Guys? Okay, SV is ADV minus ESV, so that's 70. So 120 ml, right? Minus 150 ml. Oh my God, this is elementary math. And then your SV, current output, is calculated multiplying the heart rate and the volume. So that heart rate times SV, how much heart rate do we have? Per minute?
75.
75 times SB. What's our SB? 70. That's your cardiac output. 70, I put it 72. It's 75 times 70 is 5.0.4, or multiply 75 to 70, that's 5.2 liters.
I know.
Got it?
Yes.
Okay, now let's go to the factors of the influence of the volume. This is very important because volume has to be exact. What the volume of blood that come into your heart from the right atrium has to be exact volume that come out to your aorta.
If it's not equal, what happens?
You have congestive heart failure, so you need heart transplant. Okay? So these are the factors: preload, contractility, afterload. What are these? Please remember these words. So what is preload? Preload is the length or degree of stretch, the sarcomeres or the cardiac muscle, in the ventricular cells in the ventricles before they contract. That's the action potential, right? That's your depolarization. So how much is the stretch, the degree? Okay? Major factor of preload is how much is your end diastolic volume. What is your end diastolic volume again?
The actual potential.
How much?
Relaxation.
The
20
EDV
is
120.
120 ml.
Remember that I told you to remember these numbers. ESV is 50. Okay? So we got that. So then we have here, so ADV increases when the ventricles spend more time in diastole. That shouldn't be good, or it shouldn't be bad. It's relaxing. No. ADV increases when the ventricles contract, more force to increase the venous return. There is not balance. Venous return is the amount of blood returning to the right ventricle, okay, coming from the right atria. So those are important measures in the preload. Okay, so that's your preload. You see these. How much is that volume that can stretch your muscles here? Got it? So that the strength of your muscle, cardiac muscle, is very important for the preload, because that's how much you say. This is the Frank Starling law. Remember that Frank Starling law, because when you go to your upper A&P, this is always remembered. So relationship between the preload and the stroke volume. So how much is the strength of your heart is that how much is the volume, stroke volume that you can give to your aorta or lungs. Okay, here, the more ventricle cells are stretched, the more forceful they contract. So stroke volume will depend on the quality of your sarcomeres or of your ventricular muscles. That's why if a person has infarction, ischemia, when the part of the heart muscle is dead, they cannot inject 70 ml stroke volume, no. Because it's weak. Because of the Frank Starling law. Okay, so stretching causes more optimal overlap of these myofilaments as a result of contraction, so you have good stroke volume. Okay, so athletes are very good having that stroke volume. That's the reason why even if their heartbeat is very slow, they have enough blood that gets out from their aorta because their muscles are very good. That's how it is explained. Okay? So, 2, contractility, contractile. Yeah? Ability of the heart to generate tension. So, that's again another example. So, increasing contractility will increase the stroke volume and decrease the end systolic volume so that when there is decreased contractility, it will increase the stroke volume. Okay? We call this, so there are agents, there are chemicals, there are pharmaceuticals, drugs coming from